A major challenge in XR telepresence is the high cost and complexity of streaming immersive media. Traditional codecs force a trade-off: high quality with heavy resource use, or efficient compression with reduced quality, both limiting the user experience. Our solution is based on codec enhancement. We use the MPEG-5 Low Complexity Enhancement Video Coding Standard, LCEVC, on top of H.264. LCEVC improves compression efficiency while maintaining visual quality and lowering CPU usage during encoding. In the 6G-XR OpenCall 3 experiment, Fluendo integrates LCEVC to enhance the remote renderer and the video player of the 6G-XR platform. The remote renderer captures and processes complex XR scenes at the network edge, producing high-resolution 2D or 360-degree mono or stereo video streams for real-time delivery to lightweight client devices. Originally, the system relied on H.264 encoding and decoding only, with traditional transport protocols such as RTP, DASH, or WebRTC, limiting quality and increasing latency. The enhanced pipeline introduces three major innovations: LCEVC encoding on top of H.264, low-latency streaming using quick web transport, and browser-side LCEVC decoding via the Fluendo open-source project gst.wasm. Together, these components reduce bandwidth use while improving visual quality and lower the computational load at both encoder and decoder. Combined with Web Transport and GStreamer, this enables low-delay rendering through remote computing and cross-platform integration across devices. LCEVC, as an enhancement layer, maintains backward compatibility with existing H.264 infrastructures, ensuring smooth integration with current XR applications and hardware. The gst.wasm framework extends playback to the web browser, allowing XR experiences without native installations, fully portable and cross-platform. The user opens a terminal and begins editing the script site's webtransport.sh script, which configures the parameters for a GStreamer pipeline in a Kubernetes deployment. Inside the Nano editor, the script's configuration is shown, where key parameters for the video server are defined. This includes the video source, 2D, 360 mono, 360 stereo, the codec, LCEVC, OpenH.264, resolution, 720p, 1080p, 4K, and bitrate, 1, 2, 5, 15 megabits per second, which are used to optimize the GStreamer pipeline. The user saves and exits the script. They then run it to start the deployment of the pipeline server. The terminal confirms that the renderer has successfully started. The kubectl logs for the Vicom renderer pod are displayed. These logs correspond to the GStreamer server running in the pod, showing the initialization and status of the pipeline. The user opens a browser that acts as the video client. It connects to the IP address of the Kubernetes deployment to receive the video stream. The page displays the client's interface. The user interacts with the video player. They then modify the IP address and port to connect to another deployment of the pipeline server. Once connected, the video starts playing. The user inspects the browser logs, Chrome, to analyze client performance metrics, such as end-to-end latency and frame rate, visible in the console logs. We conducted extensive latency measurements on the enhanced pipeline. Each experiment combined different resolutions, 720p, 1080p, and 4K, with three content formats, 2D, 360 mono, and 360 stereo, under various network conditions. We compared the encoding and end-to-end latency of AVC, H.264, against AVC plus LCEVC under identical streaming conditions. Results show that LCEVC adds a modest encoding overhead, around 20 to 45 milliseconds depending on resolution, while maintaining a viable end-to-end latency for interactive XR. The impact is most visible in 4K, where encode time increases, but bandwidth efficiency and visual fidelity improve significantly, as shown in tests measuring perceived visual quality. These results validate the integration in the 6G-XR platform and confirm low-latency viability for real-time immersive streaming with LCEVC enhancement. The result is a scalable, enterprise-grade XR telepresence solution that is cost-effective, energy-efficient, and accessible to a broader range of users. Reducing resource consumption enables greener multimedia, lowering the CO2 footprint of streaming and telepresence services. With these innovations, the 6G-XR platform becomes more efficient, sustainable, and ready for real-time holographic communication over next-generation 6G networks.